Hey there, happy Thursday to you. So now that it's Thursday, it is review day, so this is the review you got yesterday. So we're going to go through this review in great detail. I will do, hopefully I'll do both. Maybe I'll do one of each, one problem, give you an idea of how to do it so you'll know what's going on. So I'll do the answers in red. All right, convert from decimal form to degrees, minutes, and seconds. All right, so you got to go degrees, minutes, seconds. Now, minutes and seconds is a hint. 60 minutes in an hour, or in a degree, 60 seconds in a minute. So that must mean I've got to do something with 60. If it's a decimal, it got smaller, so you got to make it bigger. So we're going to take the decimal only. It's 110 degrees. That stays the same. So now I got to find the 0.58. 0.58 times 60. That will get me the first part of it. So pull up my calculator again. Turn it on. 0.58 times 60. 34.8. So the next part is the 34. 34 minutes. Now I got to do the 0.8 times 60. So we got to do the 0.8 times the 60 because remember you got to get rid of one piece at a time. 0.8 times 60. That's how many seconds there are. There's 48 seconds. All right, so let's do that again. The 21 stays. So now I got to convert this 0.411. 0.411 times 60. 24.66 times 60. Remember, I keep taking the decimal. That last one you can't do anything with. So it's 2439.6. 2439.6. Last one you can't do anything with that last one. It's as far as you can take. You can have a decimal in the last seconds position. You cannot have it in the minutes position. All right, so we're going to go the other way now. Let's go from degrees, minutes, seconds to decimal. So you're going to divide by 60. That's going to give me a first part of the decimal. So we're going to start with the 21. So let's get rid of this stuff. 21 divided by 60. 0.35. So the next one is 42, and then take the 0.35 that we just got from our seconds and divide that by 60. And then put those two together. So now you get 61 stays. So it's 61.70 70583. Repeating. If you didn't go that far, that's fine. You don't have to go that far. So let me show you again what I did. Took the 0.21, start at the end, divide by 60, gave me a decimal. Take that decimal, put it next to the 42, divide by 60, that's the decimal for the whole thing. So on number 4, I'm going to take 3, divide by 60, take the 2 with that answer, that decimal answer, divide that by 60. That's your whole decimal, so it's 1.034. 1.034. Nearest 100, 10 hundred, so you could have just gone 0.3. That's fine. Degrees to radians. So you got to get rid of degrees. Pick up radians. Multiply. So you're multiplying that by pi over 180. Multiply that by pi over 180. Radians to degrees. This is 180 over pi. If there is no pi in the problem, like number 3, just multiply these. It's fine. The pi's don't have to cancel out. This pi has already been built in, so just whatever it is, type it in. Type it in the calculator. See what it spits out. Use your calculator to evaluate. Make sure you are in degree mode for these. In radian mode, for the other ones. For 11, like 11, your calculator has two modes. It's either a degree or it's a radian. It's a degree, so my mode should say degrees. So I would do 9 and 12. 10 and 13, got to do some converting to decimals here first. 11 and 14, I got to change this to radians, so I'll come back to that in a second. Let's do 9 and 12. Sine of 20. 0.34. Cosecant, which is the reciprocal of sine 1 divided by the sine of 13. 4.4. All right, let's jump to radians. So let's go radians. We'll go down, change your mode to radian. It's either that, you could convert these to degrees. Up to you. It really does not make a difference to me. In radians, though, I can just go the tangent of pi. Oops. Pi over 7. Now you're in radian mode, so the answer will come out okay. That's a mistake people make, is they don't check to make sure they're in radian mode for these. Make sure you're in radian mode. If you're not, I'll be able to tell, and I'll just mark it on your test that says should have been in radian mode, should have been in radian mode. It's not a huge mistake. It's just a minor one. 1 divided by the tangent, because that's cotangent, of 2 times pi divided by 3. Negative 0.57. Or 5/8. These other two, you've got to do some converting, so let's convert those quickly. So we had 5 over 60. This is for number 10. 5 over 60. 13.083 over 60. This calculator's giving me problems. Over 60. Did it again. 13.083 divided by 60. 60. So you're going to take the cosine of 12 degrees, 0.21805. There's your answer. Secant is the opposite of cosine. So let's do the 34 over 60 for number 13. Now secant is 1 over the cosine of 82.56. All right, 1.56. Number 10 was 0.94. Check your mode. Make sure you check your mode. Find the exact value of the following trigs without using your calculator. You can use your calculator on everything, so don't worry about that. That's just the same as above. You're going to use your calculator for everything. There is no such thing as without your calculator. So that's the same kind of thing. Make sure you're in the correct mode. Radians, you got to be in radian mode. Degree mode. Do all of you're currently in radian, so I would do all the radian ones first, then come and do the degree ones. Arc length. Arc length equals r times theta, and remember theta is in radians. It's your formula. S equals the radius times what fraction of the circle? Radius times a fraction of the circle. How much of the circle do I have showing? Which is in radians. Theta is in radians. So if it's already in radians, there's no converting necessary, just plug in. S equals 10 times 1/2. This is in degrees, so I convert that to radians. S equals R times, let's convert, 30 over 180 times pi. And the radius here is 3. Theta is 1/3 radians, S is 2. So 2 equals R times 1/3. Do some algebra, multiply by 3, R is 6. Find theta, S is 3. 5 times theta. Theta is 3/5. Do some algebra. Hour hand on a clock is 3 inches long. How many inches does the trip of the hour hand move in 2 hours? All right, so you have a clock. Hour hand, 3 inches. How many inches does the trip of the hour hand in 2 hours? So here's 1 hour, here's 2 hours. How much of the circle is 2 hours? Well, in a circle, there's how many hours? There are 12 hours in a day. So 360, divide that by 12. Each hour marks out 30 degrees. All right, so you got to convert that to radians. So the arc that it marks out is S equals 2 hours, 3 inches long. 2 hours is 60. Convert that, pi over 180. Think about the problem. Draw yourself a picture. It helps. Solve for the missing variable. This is trig. Simple trig. What ratio is this? This is opposite, hypotenuse, and adjacent. I have adjacent and hypotenuse, so that's cosine of this symbol, which is alpha, equals adjacent over hypotenuse. But I want the cosine of alpha. I want alpha, so I have to get rid of cosine. The way you get rid of cosine is to undo cosine, which is, remember, called the arc cosine. It is a second function. Second cosine of 7 over 13. Ooh, I'm in the wrong mode. Excuse me. What's the difference? Notice the difference? Huge difference. Got to be in the right mode. 57.4. Now I'm in the right mode. All right, now 27. You got to find x. Here's where I'm looking. Here's the hypotenuse. Here's the opposite. Opposite hypotenuse is a sine. Sine of an angle. You never go sine of 90, by the way. Remember that. Never, ever, ever. It is the opposite over the hypotenuse. Let's do some algebra. Multiply by x, divide by sine. Throw it in the calculator. Let's see what the calculator has to say about this. Divided by the sine of 61. .37. The radius of a wheel on a car is 15. All right, so this is 15. 3 revolutions per second. How fast is a car moving? Express your answer in inches per second and miles per hour. Okay, so inches per second first. So we're going 3 revolutions per second. So let's figure out how much a revolution is. So the circumference here, 2 pi r. So it's 30. Pi is 1 revolution. It's going 3 revolutions per second. So this is 1 revolution, so you have to multiply this by 3 every second. So that's going to be 90 pi is the total distance that it's doing in revolutions per second. So in 3 seconds it's doing that many, that's how far it's going. Oh, you know what, I messed that one up. Let's do what the problem says. We already did this kind. So it's 3 revolutions per second. I want to find out what the total is in inches per second and miles per hour. So I'm going to make some room and do this one for miles per hour. So okay, let's see. Revolutions per second. So seconds I don't have to do anything with. 3 revolutions in 1 second. So seconds will stay there. So I got to convert revolutions to inches. Times 1 revolution is 2 pi r, or 30 pi. So now I multiply these together. You get your total, which was my answer from before, 90 pi. The other way, I was just giving you the answer. This way, we're thinking about what it is we're doing. All right, so now I got to go to miles per hour. So let me open up a new page here. We'd have 3 revolutions per second. I want to get to miles in an hour. All right, so I got to get seconds to hours, so let's work on that one first. So 60 seconds is 1 minute. And then 1 minute, or 60 minutes, is 1 hour. So let's see, am I getting to hours? I'm at hours. Seconds go away, minutes go away. Okay, now I got to get to miles. So I got revolutions. So I can go revolutions to inches. Let me move this stuff down. So let's do the next part. The next part is now I've got to change how I'm getting there. How am I going to get there? Well, I've got to change revolutions to, I can go to inches. 1 revolution, we just said, is 30 pi inches. I can go from inches to feet. 1 foot is 12 inches. How many feet are in a mile? 1 mile. So I want mile up top. I want to get rid of feet. That's 5,280. Cancel out, follow your units. Revolutions went away. Inches went away. Feet go away. You're left with miles up top, hours on the bottom. So now it's just a matter of typing it all in. All right, so it's 3 revolutions. 3 times 60 times another 60. That's the second 60. Times 30 over 30 pi times 30 pi. Now I'm going to divide by 12. And I'm going to divide by 5,280. So let me find this answer first. And divide that by 5,280. I didn't hit the divide one more time just because I don't want to screw it up. So we're looking at a 16.06 mph. This is a good problem. I like that kind of problem. It's got a lot of stuff there. Ship is off the shore of New York City. Statue of Liberty is 350 feet tall. The angle of elevation of the top of the statue. Again, we're going to draw the same old triangle. Elevation and depression is the same angle. It's down here. That's elevation. It's also depression. So even if it said depression, it'd be down here. How far is the ship from the base of the statue? I don't know. We'll put an X there. All right. We have hypotenuse. From 20 degrees, we have the opposite. We have the adjacent. So I have opposite and adjacent. So that's a tangent of theta, which is 20, equals 350 over x. Let's make some moves here. Multiply by x, divide by tangent. 350 over the tan of 20. Throw that in your calculator, see what you get. Make sure you're in degrees. This is another right triangle trig problem, so we're just going to go ahead and draw the right triangle to measure the height of a building. Two sightings are taken from distances of 50 feet apart. So this is 50 feet apart. That's 50, that little distance. If the first angle of elevation is 40, the second one is 32, what is the height of the building? Let's work it out. This is the height of the building. We'll call that h. We'll call this first part x, and the second part is going to be x plus 50. All right, so let's set up the first ratio. Let's look at this first triangle. Let's highlight this first triangle. First triangle is here. You're going to have to think about this one now. So let's think about this. Opposite. Now I'm going to use capital H instead of lowercase h because I don't want you to get confused with my symbols. We use capital H, which is different from hypotenuse. So this is O, x is A, this is H. Alright, so let's see. We've got opposite that we want to know about, and we've got adjacent that we want to know about. And we got 40. OH, so that's the tangent of the opposite over x. That's a tangent of 40, so let me move in the 40 there. Alright, that's the first one. So now let's look at the second triangle. There's two triangles here. Second triangle is the blue one. Second triangle, you know this about it. You know that it's the tangent of the opposite. Well, actually, it's tangent of 32, opposite, over the entire distance, which is now x plus 50. Remember, these ratios are nothing more than decimals. Tangent of 40 is a decimal. So let's see what that decimal is. Tangent of 40. That's 8.4, or 0.84. 0.84 equals h over x. So let's figure out what h is. H is 0.84 x's. Look at that. There's another h. I'm going to replace that. But first, let me find out what the tangent of 32 is. Tangent of 32. Again, it's another decimal. 0.64 will go. equals, instead of h, I'm going to put in 0.84x. And on the bottom, you got x plus 50. Solve the equation for me, please. I'm going to do some cross multiplying, so it's 0.64 times x plus 50 equals 0.84x. Distribute 0.64x plus, let's see what 0.64 times 50. 32. Solve for x. We're going to subtract the 0.64 from both sides. 32 equals 0.20x. Divide by 0.2. (32) divided by 0.2. 160. So x is 160. What does it want to know? The height of the building. That didn't answer my question. That's x, but I do know the height of the building. It's 0.84 times 160. Now I can answer the question. So it's 160 times 0.84. Height of building is 134.4. All right, again, this will be on YouTube. Try these problems. The best way to review, I'll tell you right now, is to go through the problems over again. Make sure you understand them. Make sure you can do them cold, which means I can do them from the beginning. I can pick up this thing. I can look at it. I can figure out what it is I need to do. I can repeat it. Do the problems and then watch the answers again. Look at the answers on YouTube. Get on there, check it out. Make sure you understand what it is I'm doing, why I did it. Make sure your answers match. All right, so this is available for you. Use it. Do something with it. There's going to be another small review, same kind of thing. I won't have the answers for that one though. Or maybe there'll be a bonus. I'm going to put those answers only on YouTube. So if you want to look at those answers, I'll put those answers out there. But the review sheet I'm going to give you today is another review sheet for tomorrow's quiz. It's going to be slightly different. Good problems. Those answers will only be on YouTube. So I want you to try these. I want you to practice them. Go home, check those answers on YouTube. All right? So the sub will pass out that review sheet now. Work on that the rest of the time. Go home, look on YouTube, get the answers for that second review sheet. Make sure you understand the questions. Good luck on the quiz tomorrow. I will see you on Tuesday because we have Monday off. So have a good weekend. Good luck on the quiz. See you Tuesday.